All righty. Loops are fun, aren't they? So tonight, last class before spring break, hope everybody's looking forward to it. So there are so many different, that when we get to this point, like I've been saying, you've got if statements, you got loops, got all the different variations, all the tools and stuff in your tool belt now. We can go all kinds of different directions with all kinds of crazy programs and make them all very complex and just get crazy with it. But the main thing I want to try to do when I give you some weird looking problem, there are a number of really common patterns that you're going to see very often. And I want to just try to hit on all of those and give you an example of each one of them that I can think of that I know that you're going to run into. So, we've got plain old basic loops, what we would call sentinel control. We've got counted loops, nested loops. And the idea is if you've seen it once and then you see another problem or you imagine a problem on your own, something that you think would be cool to create, then I'm hoping we can spark your imagination and give you the tools to be able to just implement it yourself and not just do the assignments that I'm giving you. So on each of these, the key things I want you to get are looking at a problem, either in your head or one that I give you. Pick out the items in that problem that you think, oh, that's probably going to require some repetition control structure stuff. The flowgram or the flow chart for it, we'll go over some of the examples of that, but I want you to be comfortable with how to flow chart these algorithms that we're going to come up with. Obviously, how do we write it in Python? And last class, I know, was kind of a grind. It was pretty long. And it was mostly theoretical. We didn't do much actual Python programming last time. But tonight, I'm hoping that it's much more practical and much more flowgram and Python focused. Again, with the caveat that my job is not to create a bunch of Python expert clones, but to give you the tools that you need to implement similar algorithms in whatever programming language that you decide to learn after this, that you'll understand the concepts. And this is one thing that I've always felt very strongly about, is that first you program the algorithm in your head, and then you express that algorithm through your keyboard onto the screen. If you don't really understand what the sequence is, what the logic is supposed to be, and you can't express it, that's why we spend so much time worrying about these silly pseudocodes, right? Because you need to be able to just spit it out in your own words. What is this program supposed to do? And if you can do that, the rest of it's gravy after that. Okay, so common loop patterns. We know the sentinel loops. We have some special value in mind or some condition that we know is going to become true at some point in the future, and we're going to loop until that becomes true. We want to remember the basic pattern of setting your initial condition, checking the loop condition, and modifying the loop condition inside the loop. Because if you don't modify the loop condition inside the loop, it's just going to loop forever. So then we can get into all the different nesting variations where you can have a loop within a sentinel controlled loop. And this is the classic, keep doing this until I say quit, right? As soon as the user enters 0 or -1 or quit, we're going to keep doing whatever the problem is. So we can get really interesting with that. We can say, hey, enter a number. And if you enter 0, we're going to stop. We also have counted loops within counted loops. And remember, nesting just means loop within a loop, right? Nested if statements or if statements within an if statement. Nested loops are loops within loops. So a nested counted loop, commonly we would run into that if we're doing something that's row and column based, right? If we're going to have a grid of stuff, then we would probably have a counted loop within a counted loop. So solving problems multiple times, we might vary what we do inside the loop each time through the loop. And that's where the logic can kind of get hairy. Another pattern, and we haven't used this term before, I don't think, is a loop that has control breaks in it. And control breaks is terminology if you, like when I was learning programming back in the Stone Ages, we did a lot of reports. Back then, you had the green and white alternating perforated paper with the little dots down the sides. Well, what we had to do a lot was print reports on those pages. And then whenever we got to the bottom of a page, we'd have to stop and print a line of subtotals. So you'd have a subtotal for this page of information. And then you go to the next page, print another page of information and have subtotals at the bottom of it. Then you flip all the way to the end and you have the totals that kind of include all of the previous subtotals. Yeah, and what they would use those subtotals for is if you had a logic issue, you could isolate it by just looking at that one page. If you could manually add up all the numbers and they add up to your subtotals, okay, we're good. Without having to say, well, are all 10,000 pages of this adding up to the right number? You could troubleshoot it. But a control break is something like that, where you're stopping in the middle of your regular scheduled programming, no pun intended, and you do something exceptional, but then you continue looping. That's a control break. Yeah, and then your number of pages would be the total number of lines in your report divided by however many lines per page you have. So we often had to worry about calculating that because, if you have 57 lines in your report and you're doing 50 of them per page, you'd need to know how to calculate how many pages, because it would be the number of lines divided by the number of lines per page plus 1, because you have that remainder at the end, right? The 7 that go on the last page. So anyway, it's a very common pattern to run into that kind of logic. Okay, so here's an example problem. Like I said, we're going to get into this practical side of this really quick tonight. So let's say, it's supposed to say ask. Ask for individual words and add them to a string until the user enters quit, then print the sentence. Okay, that's not too bad, is it? We can do that. We're starting simple. Okay, we get a word from the user. While the word isn't quit, we add the word to the end of the sentence, and we ask for another word. Then after we get done with the loop, we print the sentence. So that's our pseudocode, right? We've set our initial condition by asking for the first word from the user. We've checked our loop condition while the word isn't quit. We do some work, add the word to the end of the sentence, and then we modify our loop condition by asking for another word. So it's got all the proper components of it, and it does what we were asking it to do. And as we know, the word quit is our sentinel in this example, and we'll just keep looping until we get it. So here's another pattern for doing the same thing. Okay. We start looping forever. We just say while true, right? It's an infinite loop as it's coded. We didn't set an initial condition, right? We just said start looping while true. Ask for a word. If the word is quit, then we break. So this is one of those, remember the term that I used for this? If the one on the left is a pre-loop test, what's this one? Mid-loop test, right? We're testing for our end condition mid-loop. So, so right in the middle of the loop, we say, hey, if we hit our sentinel, let's get out of the loop. If not, then we do the work that we're here to do, adding the word to the end of the sentence. So that's just going to keep looping, looping, looping. And then eventually they enter the sentinel, we break out of it, and we go down and we print the sentence. Those two do exactly the same thing. They're about the same number of lines of code. The only thing I would say is perhaps I've got a preference for the one on the left, because in my experience, it's a little bit more structured, what we call structured programming. The one on the right is a little too much feeling like a go-to in there a little bit, and just kind of makes the little spidey hairs on the back of my neck stand up. But they do the exact same thing. They're both perfectly equivalent implementations of this. Okay. Next example is counted loop example. I kind of gave it away. Print 1 Mississippi, 2 Mississippi, 3 Mississippi until we get to 10 Mississippi, and do each one of them on a separate row. Silly example, but it's a great one. We're told our start value and our end value. We know exactly, it's definite repetition. We know exactly how many times we're going to repeat. So it's a perfect opportunity to use a counted loop. So here's our pseudocode. And I'll make this point again. It may be hard to figure out how to say what the pseudocode is, but if you can't program it in your mind, if you can't say it in your own words, how are you going to write the Python? I think that's honestly, if I had to guess, one of the reasons why people have so much trouble with the flowchart is because by the time you get to the Python code, you have to figure out the exact precise logic, the exact lines of code that you have to type in. And that's when you finally make yourself figure out what the logic is supposed to be, right? By the time you do the flowchart, you haven't made yourself do that yet. So if you stop and make yourself do it when you're doing the flowchart, maybe the Python would be a lot easier, and maybe the flowcharts would be more precise too. So just a theory. Okay, this one, the pseudocode is a lot easier. Count from 1 to 10. And for each of those values, print that value followed by Mississippi on its own line. 2 sweet, simple little lines of pseudocode, and we're done. Here's the Python for that. Right, those of you that have done the previous example, you're getting comfortable with this already. For index is the name of our variable. And there's one of those range functions. So I'm creating a range of values from 1 to 11. Remember, I say 11 because I have to make it one more than what I want it to be, where I want to stop, because the logic inside this range function uses less than, not less than or equal to. And there's historical reasons for that, but at this point, you just have to remember that that's how it works. You have to use as your stop value one more than where you want to actually stop. So since we want to go from 1 to 10, we have to say 11. That's just how it works. And then we have a simple print statement, the index plus Mississippi. Easy cheesy. Here is, like with the previous example, here's another equivalent. It's doing the exact same thing, but I'm doing it without the counted loop. Remember, anything that we can do with a counted loop statement, we can do without one with a simple while, right? The counted loop examples are always a special case of the plain old while logic, no matter what language you're looking at. So I set my initial condition, count as 1. While count is less than 11, I've checked for my end condition. I do the work. I modify my loop condition. I add 1 to count, and then I end the loop. So they do the exact same thing. Okay, this is one of them that I think is important to do the flowchart on. So let's do that. See if I can make it big. All righty. So I'm going to declare a variable first. I think I called it index. Variable name is index. It's an integer. And please raise your hand if I lose you, if you fall off the map here and I go too fast, or I do something magic and you didn't see what I pressed. And I'm going to just do this like the simple one on the right, because to me, it's a lot easier to flowchart it if you don't assume you're using the special case counted loop part of it. If you can always convert it in your head back to the simple while loop form, then it's a lot easier to flowchart. So setting my initial condition, I'm going to use an assignment box. Say index equals 1. Sorry, on these little dialogues that pop up, it's really small. So if you can't see what I'm putting in there, just holler. But that says variable name index, and I'm going to just set it to 1 for my initial condition. Okay, now I've got a while. So I'm going to use one of these funky little boxes. And this is a flowgorithm thing. I mean, it's very useful, but you just got to figure out how flowgorithm works. While what? While index is less than 11, right? One more than what we wanted. And while that's true, I'm going to do an output, and I'm going to print index plus Mississippi. And I think that's pretty much it. Want to take bets on whether it works? Or did I slip in a bug in there just to see if you guys were paying attention? Okay, let's try to run it. Type mismatch. Add operator requires 2 numbers. Where? Oh. Okay. And? Yeah. Like that? Yeah. That's how you concatenate in flowgorithm? Okay. So it's going and going and going and going and going, right? What did I forget? I'm looking for a particular phrase. What did I fail to do? Yes, I failed to modify my loop condition. Index equals index plus 1. There we go. That's probably going to work a little bit better, right? 1 Mississippi, 2 Mississippi, 3 Mississippi, all the way up to 10 Mississippi. Boom, did it. Everybody get that? So that's what a loop looks like in flowgorithm, if you hadn't figured that out yet. I set my initial condition, I checked my loop condition, I did some work, I modified my loop condition. Everybody okay? We can go on. I can, let's see what the, where is it? I wanted to view the, there it is, view source code. So here's a good rendition of what our pseudocode might look like, right? You okay? Right, that's very similar to what my pseudocode might look like if I just wrote it out by hand. Okay, I'm not hearing anybody right.
Yeah, I have okay. The output index A Mississippi, mine's not letting me, it's saying I have a typo error. Expression contains a typo. This is often caused by forgetting to include an operator having an unmatched parenthesis. There was right on the following, the product, the addition symbol.
Yeah, instead of plus, use this and symbol. I did the same thing initially.
Oh, there it goes. Thank you.
Somebody actually asked about that in their comments on their assignment, I think, and I said, yeah, I don't know either. Just Google string concatenation, flowgorithm. I'm sure you'll figure it out. There'll probably be an example somewhere. So in flowgorithm, ampersand is string concatenation. Yeah, do you have a question, Bradley?
Yeah, but
Hmm? Okay. The if, like, if I only wanted to do the even number ones, let's say if index mod 2 equals 0, something like that. You know, I could print even. So that's what an if statement would look like if I threw one in there. Has nothing to do with this particular assignment, but that's what it would look like.
Now, on if statements, if there happens to be a false, and you need to go back in an if statement, how do you do that?
You use a while.
Wow.
Yeah, this little orange box.
Yep. Okay.
Right, an if and a while are different. So,
But you use that on the false.
well, false means we've exited our loop.
Okay.
Let me zoom out on this a little bit, right? When you take the false path on this while box,
Yep.
you fall out to after the loop is done. While the loop condition is true, you keep looping. When the loop condition becomes false, you fall out the bottom of the loop.
All right. Okay.
Making sense?
Yep, that makes sense.
Okay, well, we'll do that after we get done with this all then. All right, so I'm going to continue on. Did you actually say, wait 3 seconds after I close the flowgram?
I'll do like process like what like you trying to detect like you can't be like less, but it can't be greater than like you gotta be in the middle.
It has, the loop condition has to be true.
Right.
Whatever you're testing has to be true. Remember we talked about Boolean conditions? You know, if X is equal to 5 or if Z is less than 10, whatever your expression is, it has to be true to keep looping.
Yeah, like let me give you an example. Like X is greater than 1, but less than 3.
Then you would say and, you say X is less than 1 and X is less than 3. So you have multiple conditions and you're combining them together into a compound condition with and or not.
Oh, okay.
That's called a compound Boolean condition.
And you put that for a while.
You can make one if statement out of a very long, complicated compound condition if you want to. You don't have to nest them. You can combine them together with and or.
Oh.
Good stuff. Good questions. Okay, now I'm going to do a counted loop within a sentinel loop, another common pattern. So here's our problem. I want to ask for numbers from the user until they enter 0. As long as they haven't entered 0, whatever numbers they entered up to that point, I'm going to add up, continue adding up into a sum. And whenever they enter 0, I'm going to display the sum and then whatever the square root, I'm making this up, but I'm going to display the sum and the square root of the sum. Then outside of that, I'm going to keep repeating this until they say, no, I don't want to keep doing this. So I've got a sentinel loop on the outside, and then inside I'm going to ask for numbers until they enter 0 and do some work. And then I'm going to go ask them, do you want to do it again? I'm going to keep asking them if you want to do it again. So it's a little bit more complicated, but it's just You know, it's like Mexican food. It's just recombining the same ingredients in different ways and calling it a burrito. Okay. Okay, let's see if we can do the pseudocode for this. All right, so I created this variable called go again. And I'm going to set the initial condition to yes, I want to go again. Because the first time through the program, yes, I want to go once. So my loop condition is while go again is not equal to no. Well, that's kind of obvious since I just set it to yes. I know it's not equal to no. That's fine. It's the first time through the loop. So that's what I want to happen. So inside that big outer loop, I'm going to say, set the initial condition, right? I'm setting the initial condition again because it's a separate inner loop. So set the initial condition, sum to 0, ask for a number. While it's not 0, add it to the sum, ask for another number. Loop, 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 loop. Eventually they enter 0. I get out of the inner loop. I print the sum, I print the square root, and then I say, do you want to go again? They either say yes or no or something else bizarre. But I keep doing that outer loop until they say, no, I don't want to go again. Okay? When I say it like that, it sounds so easy, right? Yeah. If all of the homework was me posing a problem and then giving you the answer, yeah, it'd be easy to do all the assignments, wouldn't it? Okay, let's see if there's another variation of this. Okay, the one on the right, a little different structure, but I believe me, they both do the exact same thing. So the one on the right, it just says start looping. It's while true, loop forever. Okay. Then on the inner part, you notice this looks very familiar. I'm doing the exact same inner work for the inner loop as I did on the left, but I did it differently. The one on the inner loop on the left has a pre-test. The one on the right has a mid-loop test. I'm using the break thing. Start looping. So I've got a while true within a while true. Ask for a number. If the number is 0, break, we're out of here. Otherwise, add it to the sum. Keep looping. Okay? Everybody all right with that? Two completely different looking ways of doing the exact same program. The same output, same logic. Well, not same logic, but same results. Everybody believe me? Okay. Well, let's try to flowchart this, shall we? Okay, which one do we want to do? The one on the left or the one on the right? Which one would you rather have an example of in your notes? You want the left one? Okay. All right, so first thing, I'm going to declare my variables. What do I need? I need go again, which is a string. I need a number and a sum and a square. I think that looks like as many variables as I would need. Okay, set go again to yes. So I'm going to set my initial condition. Yes. Again, apologize for the type being so tiny. It looks bigger when I get up here. While it's not equal to no, so I'm going to add a while. And did you see where I got that over on the right? It's got while, it's got for, and it's got do. A while.
Oh, go again to yes.
Yes. Set go again to yes. while go again is not equal to no. Now we're in the inner part of it. So while we're looping, now I want to start my inner loop. So set my initial condition, set sum to 0. Now, when I was coming up with this problem, just to give you a hint, I initially didn't want to put this set sum to 0 line in here. But think about what happens if I don't do that for a moment, and then we'll revisit this. If I just don't have this line of code in here, set sum to 0 on the inner loop. Just think about that. So inside here, I'm going to have another while. I'm to this while not 0. So while what is not 0? Oh, actually I need to ask for a number, don't I? Set sum to 0, ask for a number. So I need an input. Variable name number. Input number. Now I can put my while. While number not equal to 0. And then add the number to sum. There's an assignment. Sum equals sum plus number. So everybody got that pattern? You'll see that a lot. Add something to something else always means that something else equals something else plus the something. That's just a pattern. If I add number to sum, that means sum equals sum plus number. You'll see that over and over and over again. You'll see it so much that most languages can shorten it to sum plus equals number. So cut down on the typing. So whenever you see plus equals in a programming language, that means the exact same thing as sum equals sum plus number. But I can't do that in Flowrhythm. And then ask for another number. So I'm inside a loop and I haven't modified my loop condition. So in order to modify my loop condition, I will put another ask for a number. And there we go. This should be functional. Loop, 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 loop. As soon as number is equal to 0, I want to fall out the false path. And that's where we print our sum and our square. So I'm going to click on the false line, output. Let's see. Sum and comma space and sometimes sum. So I'm outputting the number and its square. Okay, now that's the entire inner loop. Let's zoom out a little bit on this. But I've got this outer loop. So I've set my initial condition, I've checked my loop condition, but I have not modified the loop condition inside this loop. So now before I go too much further, I want to remember, ask if they want to go again. Go again variable. And that should be it. Can I run it? Okay, please enter a value of type integer for number 12. Please enter a value of type integer for number 14. Please enter a value of type integer for number. How about 0? So So that's my sentinel. So it displays 26 and 676, which I can assume is 26 times 26. So that's a number and it's square. Now it says, please enter a value of type string for go again. So I fell out to my outer loop. Do I want to go again? Yes. So please enter a value of type integer for number. 6. 4. 9. 2. I can keep going all day long, but I won't. I'll enter 0. And so the sum is 21, and the square of that is 441. Do I want to go again? No, I think I'm good. No. And boom, we exited. So for once, we did it right the first time. All right, so have you been thinking about what would happen if I did not have this set sum to 0 in here? This is a very common bug. I put it in here, but most of the time, even I forget to do this. Yeah.
I'm guessing it takes the previous one and then like come up together.
Yes. Yes, exactly. So the first time through the inner loop, I add up 2 or 3 numbers, right? Then I say 0 and I exit and I output the sum and the sum times the sum. I say, yeah, I want to go again. I come back around, and since I didn't set sum back to 0, I just keep the same value from the previous time through the loop. So I ask for some more numbers. I keep adding those to the first sum, right? So you almost have to remember, set your initial conditions each time through each loop, right? I didn't have to do that the first time. I didn't have to, because when you declare a variable, most of these modern programming languages, they set it to a default value. For an integer, the default value is always 0. For a string, the default value is always a blank string, right? So you get away with it when you're only doing it once. But when you have this inner loop that's going to be repeating multiple times, you got to watch out for that and reset your initials. You know, back in the old days, like in the C and C++ days, they didn't do that for you. They made you initialize your variables yourself. So you had to be intentional about initializing your variables to make you think about and avoid creating that kind of a bug. But then at some point they said, that's too much trouble, you know, kind of like this. They started adding features to try to make it nice and convenient and easy and reduce code for us programmers. And they gave us crutches. Well, what do you do when you get a crutch? You lean on it. So anyway, long story short, but yes, if I had forgot to put the set sum to 0 statement in here in this part of the loop, I would have had a bug. I'll zoom out again so you can see the whole loop. It kind of looks pretty, doesn't it? It kind of starts to take on a form, right? You got your outer loop and your inner loop.
The first one you did is wild, right?
They're both while, because we wanted to do the one on the left, remember? Okay, everybody happy with that?
I had a question. Now, when go again is equal to yes, how'd you get when the program's run to be as go again as a string? Because I can run the program, but it only prints out the mathematic process of it. It doesn't ask for an input of yes or no.
Did you put the input box down here?
Input, oh, nope. That's what I was missing.
There's always an answer. Darn computer did exactly what I asked it to, right? What was it thinking?
It wasn't.
Right? It wasn't thinking, clearly.
It was following its instructions.
To the T. Okay, I'm going to close this and then you're gonna say, but wait, right? Okay. Okay, let's do another counted loop. I think I've got up next. Print numbers 1 through 10 on a row, on one row. And then print the square of each of those numbers 1 through 10 on the second row. So we got a rows and columns kind of a feel going here. So we're probably maybe going to have a counted loop, maybe nested counted loops. We'll get into it and see what we're talking about here. So I think this is my pseudocode, at least the first version of it. Count 1 to 10, and for each of those values, add that number to the end of a string. So I'm going to be just concatenating the number value to the end of a one string. And then I'm going to use that as my output for the first row. Then I'm going to start over again for the second row and count again from 1 to 10. I could use the same variable name again, it doesn't matter. And then I'm going to multiply that number times itself to get the square. And each of those squares I'm going to concatenate to the end of a different string. And then as soon as I'm done doing that, I've got my two strings. I'm going to print the strings. Sound reasonable? Reasonable way to implement that? So here's a good question. Why loop twice? I've got a perfectly good loop counting from 1 to 10. Why do it twice? Can I optimize that? So you can start right now. And hey, before we've even written a line of code, you can start saying, no, wait, I've got another clever way that might work to do this. You could. Lots of programmers do at that point. As you get more experience, you will do that. My recommendation for now is get it working the simplest approach you can think of to start with so that you have something to turn in. Don't be sitting there at 2 or 3 in the morning when you're all caffeinated and exhausted thinking, why did I do it the clever way? If I had just kept it with the simple way, I would have been done by now. You know, you can always get it done and working, set it aside, and then try the clever way if you have time. But, you know, just make sure you got something to turn in. So here's another equivalent way of doing this. So I have one loop where I count from 1 to 10, and for each of those values, add the number to the end of the string, and right then, add the square to the end of another string. Right? That works too. I don't have to have 2 separate loops. I don't have to loop twice. Maybe saves me a line of code. And then when that loop finishes, print the strings. Okay, so here is the code for that. So I'm going to have a variable called row value. This is the first implementation, the simple approach, right? I'm going to use a counted loop structure, the for in Python. For index in, the index is my variable. I got this range thing, 1 to 11, one more than I wanted, right? Because it's doing the less than thing. And then I just concatenate. Here's my little plus equals, right? If you do plus equals with a string, it concatenates them together, right? If you do plus equals with an integer, it adds it to it. When the loop's done, I print it. Very elegant. That's why we do these counted, for loops, is because they're very convenient, very simple. If you can read this in your head, oh, for index in range from 1 to 10, it's really easy to write, just like you would say it out loud. So once I've done that, and I've created my first row, I've printed my first row, then just like that set sum to 0 from the previous example, I'm going to reset this string back to blank, then do it again for the second row. And as you might guess, if I forgot to do this row value equals blank, my second row would contain everything from the first row plus everything I added for the second row. So don't do that. It's a separate loop all in itself. So set your initial condition, check your loop condition, modify the loop condition, all that stuff. Okay, let's see version 2. On version 2, it's very similar, but I have two variables, just a different way of doing it. Row 1 and row 2. One loop. I do both assignment statements inside the one loop. And then when I get done, I do two print statements for row 1 and row 2. Okay, you want to see the algorithm for this one? So far, is this helpful in terms of like, okay, seeing lots of different patterns of this so that when you get assigned something, you'll recognize, oh, that's kind of like that one assignment. I'll bet I do it similar. Yep. Okay, which one do we want to do? The one on the left or the one on the right? Both. Okay. Okay.
The
Okay.
one on the right, because in the beginning, you have the row, number 1 and row.
Yeah. Yeah. I'm happy to do both of them. That's fine. That's fine. So let's do the one on the right first. So let's see. I've got 1, 2, 3. I got 3 variables: row value 2, and index. Okay, so let me declare row value 2 as strings, and then declare what did I call it? Index as an integer. Okay. And now I get to use the cool for loop over here, the little brown box with the for loop in it.
Yeah, I was struggling with 4.
But we've already done the hard part, right? I know I want to count from 1 to 10. So I already know. So when I double click on this, variable index. Start value 1. End value 10. Increasing. Now, should I say 10 or 11? I don't know. It's probably either 10 or 11. I don't know if flowgorithm uses the less than logic or not. I don't know.
Because the other thing in Python, it's like it counts 0 as 1.
Mm-hmm. Python is always the starting value you give it to the end value minus 1. It's less than the end value. So, but I don't know about flowgorithm. It says end value. Well, the end value I want is 10. So I'm going to trust it. We'll see if that works or not. So index equals 1 to 10. We'll go with it. Inside here, I want to say sign row value equals row value. I'm going to add to row value, but I know in Python or in flowgorithm, concatenation is the and. So I want a space character in between it and the previous one. So I'm going to say row value and space and index. Does that look reasonable? And then sign row value 2, row value 2, and space character. And now I want index times index. Okay. The counted loop takes care of modifying the loop condition inside the loop for me. It's a shortcut, so I don't have to worry about saying add one to index inside here like I did before. Because it's happening, it's just happening as part of this. The machinery that is the for loop is doing it for me. And notice how the terminology changed too. Instead of true and false, it's next and done. So when I'm done, I've got my row value and my row value 2. So I want to output row value and then output row value 2. Okay, now I contend that that is the same as that pseudocode on the right. Everybody believe me? I don't think I left out anything. Let's see if it works. Variable not initialized, row value. Okay, fine. So row value equals empty string. Probably going to have to do row value 2 also empty string. And there we go. Looks like it worked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it stopped at 10 like I wanted it to. End value of 10 worked. And then the next line is all the squares from 1 to 10. Index times index.
Oh.
Yeah, here in this assignment box, I just said index times index.
That's great.
You just say index times index times index.
So you remember that.
Yeah, number times itself times itself. Everybody happy with that?
What was your output? You read it?
Well, the first row was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the second row is all the squares of those. 1, 4, 9, 16, blah, 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 up to 100.
Okay.
Yeah, I've been doing this for a while, so I remember to put the little space in between. You know, if I had forgotten to put the space character, if I just said row value times or and index, then I would have just gotten a jumble. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But clever old person that I am, I know to put a space character in the middle of it. And that way, I get it nicely formatted. I mean, you can format your print statement any way you want to, right? You can use the little colon 2F. You can, whatever it is that you're wanting to add there, you can modify it for whatever your problem is. Okie dokie. Oh, and we wanted to do the other one also, right? Okay, so the other one, we did not have 2 variables. We only had 1 row value. We didn't have that. We didn't have that. We didn't have that. So now if I run this one by itself, all I get is the first row. So now I have to do the second row. So after I've output my first row, I just have another for loop. Variable index again, 1 through 10. Just like this one. And concatenated together, row value equals row value and space and index times index. And then once again, I output row value. So all I did was repeated the loop again, but this time instead of index, I said index times index. If I run it, what did I do? I got 1 through 10, and then I got all the other stuff. So what did I forget? You know it, don't you? You know it. You're starting to recognize it. I forgot to set my initial condition back. So after I output row value, I need to clear row value. It's not 0 this time, it's an empty string, but you were on the right track. Yeah, so just like I did it up here to start this loop, I need to do it here to start the second iteration. Boom, there it is. Yeah, so this is exactly the same output as the first one. 2 perfectly valid ways of doing the same problem. So, yeah, this one equals the one over here on the left. Yeah, I didn't forget to do it over here. I just forgot to do it in the flowchart, right? Everybody okay with that? All right. Let's see what other mischief we have up next. Now, so I want to point out at this point that what we've been doing so far up to this class, you know, has been complicated. I wouldn't say they're trivial, especially if you haven't programmed this stuff before. If you've had programming classes in high school or elsewhere, you know, maybe this stuff isn't that complicated because you've already cracked it in your head. But it's looked more similar to the Lego model on the left, a few simple variations, but this is it. This is all the tools you need, and you can create the stuff on the right. You know, you can get really, really fancy with this stuff and really, really complicated with just the tools that you've got. And I think that's pretty cool. Yeah, you can do really complicated stuff. I'll show you some stuff later. Next problem. Print the multiplication tables up to 4. Everybody remember what that is? And I stopped at 4 just because I didn't want it to be silly. But you have a grid, you know, 0, 1, 2, 3, 4 across the top, 0, 1, 2, 3, 4 across the side, and each of the cells is the row times the column, right? So you get the multiplication tables. So our pseudocode is going to be, we're going to count from 0 to 4, including 4. Okay, so we'll count from 0 to less than 5, whatever, for the rows. Then for each of those rows, we're going to count from 0 to 4 for the columns. Multiply the row value times the column value. Put the value inside a variable, and then add that to the end of the string. So we're going to make each row at a time. And the main reason for this is we're writing console applications. And when we do output, we get to output one line at a time, which is a row, not a column. If we were working on computers that outputted from left to right, then we could do the columns first. But we're going to do each row individually. And our outer loop is going to be rows. And our inner loop is going to be the columns within that row. That's going to be pretty typical because, again, we work with console applications, which are top to bottom. been that way forever since computers were invented. We just have more rows and columns now because the screens are bigger. We have better monitors.
Oh, yeah.
Okay. So here would be the Python. So we have an outer loop where we have a variable called row. It's an integer. We're going to count from 0 to 4 because of the less than. It's going to be 5, right? 0 to 5. 0 to less than 5. How annoying is it that that range function works that way? And we have to remember as programmers that we always have to make it less than whatever the second number is. Isn't that annoying? But there you go. For column, in range 0 to 4, is our inner loop. So we got row and column. We multiply those two together to get our times. And then we append that, concatenate it to the end of our row value, similar to the previous problem. Then when we exit the inner loop, once we've exited this inner loop, we've got the text for one row. So we print the row. And then, because we're smart now, we clear the value of the row back to blank, and we go back to the outer loop. So we start on row 2. Concatenate it together, print it, clear it, go back to the outer loop for row 3 until we've done all of our rows. Make sense? That counted loop inside a counted loop is a very common pattern. Anytime you're dealing with rows and columns of data. So you will see that a lot. Oh. Okay. What do we want to see here? See the flow chart? This is very similar. Well, no, I guess it's not. This is the first nested counted loop example that we've done. So let's go ahead and create the flow chart for it. Okay, how many variables do I have? Row, column, times, those are all integers, and then row value. Row, column, times, and row value. Declare my variables. Row, column, times, and row value string. Okay. Now I just have a loop within a loop. Easy cheesy. 4 for row in our outer loop, 0 to 4. And inside here, we have another one for column 0, 4. It looks kind of funky because we don't have any work being done here, but it's simply just a counted loop inside a counted loop. And inside here, we're going to do times equals row times column. Oops. Times, and concatenate that to the end of our row value. Equals row value and space and times. And that's it. Okay, so now I have to think about this. So I'm on the inner loop on the right. I'm looping, 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 looping. And then I come out and I'm done with the inner loop. What do I have at this point? I've got the value for one row of text. So when I get done with the inner loop, I want to print row value. Yeah. Then, because I'm smart, I'm going to clear row value back to empty. Okay, so then it goes back to the outer loop. Then it comes back to the inner loop. But now row is equal to 1 instead of 0 the second time through. Oh, I remember too, last time I ran a flowgorithm thing, I didn't set row value. And remember it told me you're using an unassigned variable. So why don't I go ahead and do that now? I'll assign. And now I won't get that error. That's a great example of, as you get more experience, the problems that you individually hit, your brain will come up with workarounds and you'll remember, oh yeah, I'm not going to make that mistake again because I made it before and then I had to go fix it, right? Your brain will come up with those things. The person sitting next to you might not make the same mistakes you do. And so they're going to come up with different training in their mind to avoid certain kinds of problems. And you're going to come up with ways to avoid other kinds of problems because you're prone to making some kinds of errors and the person next to you is prone to making other kinds of errors. So don't be surprised if you come up with different ways of approaching these things because of that. And that's an example of how, with the previous example, we just learned something we can avoid. So we did it in advance. Surprise, surprise. Okay, what else do we have over here? Oops. That's it. So I wonder if it'll work. So this looks kind of cool, doesn't it? I've got my inner loop, got my outer loop. You can get some pretty interesting looking patterns with these flowcharts. Let's see if we can run it. Okay, so I've got 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So on the left side, I've got zeros. On the top, I've got zeros because 0 times anything is 0, right? And then I've got my multiplication tables filling each of those cells in there. If it wasn't flowgorithm, it might look prettier. It might look like a grid. If I was doing the Python, I could put tab characters in between them instead of spaces, and they would be nicely spaced out and lined up. You know, I could use my formatting codes and tell it to center each one on the tab stops. You know, all kinds of fun stuff. I can make it really pretty looking. But it's flowgorithm, so we get what we get. Let's see what the source code viewer looks like. So that's a nice looking example of what pseudocode for such an algorithm looks like. Yeah, I would consider that reasonable. You know, in pseudocode, I don't typically go to the bother of declaring my variables, but, you know, because I'm a human, I can scan through here and say, oh, here's a variable, here's a variable, here's a variable. And these programs are small enough that I don't need to declare them ahead of time and be that organized. I can just pick them out when I want to write my code. But, and again, I'll point out too, flowgorithm is not Python specific. So flowgorithm will help you even if you're going to eventually write the program in a language that requires you to declare your variables, right? So that's how flowgorithm's set up. Like a program like C# or Java or C++, you're going to have to declare your variables up front. So it's going to look a lot more like the code, like this form. Okay, we happy with that one?
How did you format your rows and your data output, because on my data output, everything's just listed one at a time.
Well, I put a space in between them, just like I did before, right?
Yep. Well, I put, my looping device, I use 4, is that correct?
Yeah.
Yeah.
Yeah, they're both 4. For row equals 0 to 4, and for column equals 0 to 4.
Okay. Well, no, 4 is in the assignment, the operator. For the loop, if it was,
Yeah. Start value is 0, end value is 4.
okay.
I don't know.
Oh,
I can come look at it a little bit.
yeah, it's all the same information, it's just one number at a time.
Well, did you do a print here inside the, did you put your output inside the inner loop?
Oh, yeah, I did.
Bingo. There's always a reason. Dang computer did exactly what I told it to do.
So when I do like the outside and the other loop, I got only the like 0, 4, 8, 7, 16, but not the rest.
Did you put your output statement in the outer loop?
Yeah.
It's supposed to go in the inner loop. So you probably put yours here on the outer loop after the outer loop says done. It's supposed to be on when the inner loop says done. Sort of the opposite of what he did. What he did was he put it on inside the inner loop, and you put yours outside the outer loop. I mean, I've got the benefit of having written these before class and testing them, so I know what works and what didn't. Yeah.
With the flowchart assignment, I got it print out, one, but I'm struggling to print out. I could just print it one.
Okay.
I've been trying to.
Okay. Well, I would trace your logic, desk check it. I think this might be a good example of desk checking, because it's one thing to just throw the logic up there. It's another to walk through it and understand what's happening. So let's write our values up here. Row value. Row, column, times. Initially, we set row value to an empty string. All right, so I'm going to start going through here. I get to row equals 0 to 4, and it's harder to desk check these because you have to remember what it looks like in a while loop. But for row equals 0 to 4, I'm going to initially set row to 0. That's all it does. I move to the next one. Column equals 0 to 4. It sets column to 0. That's all it does. Next, times equals row times column. 0 times 0. I get 0. Row value equals row value. Put times at the end of row value. Okay. 0. Then I end the loop. Come back up. I'm going to iterate again through the inner loop. So now I just have to remember, okay, when I go through the next iteration on a counted loop, I'm going to add 1 to my loop variable. So column goes from 0 to 1. And this is where it's important to understand what the value of your nested loop variables are doing. So the second time through the inner loop, row is 0, column is 1. Times goes to row times column. It's set to 0 because 0 times anything is 0. It's going to be boring the first row because it's all zeros. I loop again, set column to 2. 0 times 2 is 0. Very boring. I loop, set column 3. Well, I guess I'm also doing the 0, 0. See, your desk checking is only as good as your mind is disciplined, right? I skipped a step there. So 3 times 0 is 0. Add 0 to row value. 4 times 0 is 0. Add it to this. Then I've hit 4. So when I hit the bottom of the loop, I'm done. So I leave. I output row value. So my screen over here, I get 0, 0, 0, 0, 0. Okay. So I've done this. Now I do this. Row value equals blank again. So I wipe this out and go back to empty string. Now I enter the inner loop again. Well, actually, no. I go back to the outer loop. Now row goes to 1. Then back to the inner loop. This goes back to 0. 1 times 0 is 0. Put 0 at the end of this. And it seems very tedious because it is, but you can walk through your entire loop doing this and build up exactly what the output is. So if you're coming up with some weird kind of results, I would highly suggest, as boring and painful as it is, to step through your code one statement at a time like this. After you do this 100 times with 100 different programs, you'll recognize, well, first of all, you'll say, no, I'm not going to make that mistake again. And you'll start doing it right. But when you do it wrong, you'll quickly remember, oh yeah, this is why that kind of thing happens. And you'll start recognizing the patterns and you'll understand how to debug them quickly. You know, there's some people, like, you guys might think that it's just because I'm a genius that you say something like, hey, I'm getting this. And I say, put your output statement in the inner loop. It's because I've done that a dozen times. You know, it's not so much genius as it is, I've made that mistake many times before, and so I know why. So I've seen what the output looks like. So you just need to do this a lot. Make the mistakes, fix the mistakes, do it right, move on to the next one. Okay. Okay, that's desk checking this one. One thing I would like to do on this one is, let's see if we can do this in Python, because I want to see the pretty version. I want to see it pretty with the tabs and all that. Okay, I don't have to declare my variables. I can just start coding. For row, actually, I guess I need to say row value equals empty string. For row in range 0 and 5, right?
Yeah.
For column in range 0, 5. So I've done my outer loop, I've done my inner loop. And sometimes it's nice to just help yourself out. And, you know, give yourself a comment. Comments are free. No, surprisingly, nobody's ever caught the cold from writing too many comments in their program. Your instructor loves it because then I know, oh, you thought that was the outer loop. Oh, okay. And then it helps me give you partial credit on your assignment. Times equals row times column. Row value equals row value, and I'm I'm going to say tab. But since it's Python, I have to be more precise than this. So I have to convert my integer into a string. It won't just let me concatenate an integer. So it is what it is. But is that it? Oh, no. This is one of the things I don't like about Python is it's all indentation based. So when I come back to the column underneath 4, that is exiting my inner loop. You know, you can put yourself a comment to help, but it is what it is. I'm still inside the outer loop, but I just exited my inner loop. So I want to print row value and then set row value back to blank. Then when I get out, I don't think I've got anything else to do once I get out. Yeah, after I exit the outer loop, I'm just done. So this is that same thing just in Python. Anybody see anything obvious that I did wrong there before I just run it? What? Yes. Good thinking. Okay, I'm going to run it. Unsupported type for str and str. Oh, I hate that. Why do they do that to us? It's supposed to be plus instead of, so in Flowgorithm it's and in Python it's plus. Why? Okay, that looked like it kind of sort of worked, didn't it? Oh, look how nicely that's formatted. Isn't that beautiful? Zeros, zeros, nice formatted tab multiplication table. I love it. You know what would be better though? It'd be really nice if I had a column here that said 0, 1, 2, 3, 4, and a row up here that said 0, 1, 2, 3, 4. And then I could say, oh, 0 times 0 is 0. 1 times 1 is 1. You know, it would look prettier, right? So why don't we try to do that? Why don't we try to add an extra column at the beginning and an extra row at the start? That'd be awesome. The first one is really easy. So before I do anything, all I have to do is print 0, oh, actually tab 0, tab 1, tab 2, tab 3, tab 4. Right? It's kind of hard to read, but it's just a bunch of tabs with a 0, 1, 2, 3, and 4 in the middle. See if that does anything. Yeah, so I got my extra row. Excellent. That was easy. Well, kind of. Yeah, that's right. That's right. Now for the hard part. Now I want to skip a row, but then I want 0, 1, 2, 3, 4 on this first column of each row. So now I've got to be clever and I got to think, okay, where do I put that logic? So it's going to be on each row. So I think that means it's going to be on the inner loop. So for each row, maybe here, row value equals row. Maybe it'll work. Maybe it's not even close. Let's try it. Woohoo! That's exactly what I was hoping for. Now I've got helpers. I can say 2 times 2 is 4. 3 times 2 is 6. 4 times 1 is 4. So now it's like headers, right? What else can we do? Make it pretty. How about after this, we do a whole bunch of these. I guess I need more of them. Maybe a few more. Look how pretty that looks. Dare I try to do another divider thingy here? Let's see. Maybe one of those. Wow, look how cool that looks. You want to see the code? Yeah, so that's basically it. I could do this different ways. I could say, I could put another loop here at the top for column in range 0, 5, print tab plus column. And that should do the same thing as outline of code, right? And it's more elegant, right? I'm using an algorithm to do it instead of just making me do it. Yeah. Like you could imagine that this would work better if I said, columns equals input how many columns, right? Then I could come down here and say, anywhere I said 5 for column, I could say columns plus 1. I got to do the plus 1 because the less than thing, right? But that's not what this assignment was. It just set up the multiplication tables up to 4. So I don't have to do that on this. So I'm just saying, when you do it the smart way with a loop, instead of hard coding it, it lets you change the boundaries of the problem dynamically later if you want to. It's easily expandable if you do it the smart way instead of the hard-coded way. I don't like hard-coding things. I mean, a lot of people get really uptight anytime they see you use a constant in your program. They say, whoa, 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 why are you using a constant? What if that ever changes? You should set that to a variable, even if it's at the top of your program, you say columns equals 4. Then instead of, whoa, why do you have 5 here? Well, that's rows, but you'd always say columns plus 1. That way, if you ever decide you want your program to do more than 4 columns, it automatically expands. You just go one place and you change 4 to 7, and your program just works, right? Sometimes, yeah. Often you should think of the smarter way to do it. Yeah.
How'd you have it formatted into rows and columns? Because I'm getting rows and columns on my top lines, but everything's not formatted into multiplication table. So they get messed up somewhere, but I'm not seeing it.
Yep, I agree. It's probably messed up somewhere and you're not seeing
Yeah.
it.
In range.
Okay, so at a certain point here, I could give you the answer, or I could say, set it aside, and then later come back to it and desk check it, or just step through it. Okay, let me clean this back up a little bit. In fact, let me just get rid of that. I'll go back to the hard-coded way. So that's our header row. I added this. And this. Right, that's the program at its simplest, right? So it's on the video. You can go back and pause it at that point, compare it to what you've got, or you can desk check it and figure it out yourself. Yeah.
Yeah.
So where do I see these videos on campus?
Oh, that's a good point. I have had people ask me about that. Let me show you where in the, obviously for the people online, you'll go to your own class, but inside here, modules, if you scroll down to, let's say, unit 7 or module 7, whatever it is, I've been trying to put these right up here at the top. Like each of these modules has a learning objectives link. Okay. Oops. Went too far. Let me zoom out a little. Yeah, so this is a good example. For back in module 4. Each of these typically has a learning objectives where it just lists, here's what we're going to cover. So after the lecture, when I go to upload the video link, I usually make it the next one in the module. That way you can find it. So all of the lectures we've had so far, you should be able to go back to that module. And it wasn't here when you were initially going through it, but after we did the lecture and I had the YouTube video, I went and added this line to the module. And so now you've got a link where you can go to the video there. So where it says, and I'll try to in the future label these better, because if I just said lecture in big letters, it'd be pretty obvious. But if you click on that, then here it is. Module 4, data types and expressions, and here's the link to the YouTube video. Okay. Sure. Okay. We happy with that one? We even made it fancy. Awesome. Excellent.
For some reason, I was putting like, so I did, can I show you about that?
Afterwards. Let me keep going. Okay, next problem. I'm calling this one statistics tester. Again, I just made it up. So we're going to ask the user to enter an integer. Once we've got that integer, we're going to print a bunch of rows of 10 random integers from 1 to the number that they entered. That's where we're going to use the first number. So if you enter 100, then each row is going to have 10 columns, and each of those columns are going to contain a random number from 1 to 100, because that's the number you entered. Okay. Print a bunch of rows of 10 random integers from 1 to the number they entered. Okay, at the end of each row, print a separator. So we get to the end of the row, colon, and print the average for that row. So little twist. Now we're doing something at the end of the inner loop is the way I perceive that. At the end of every 10 rows, print a subtotal line. You remember what we called that at the beginning of the lecture? I mentioned that. What was the term? When I do something every so many rows, what is that? Control break. Yes. At the end of the whole set of all 100 rows, print a total line with the average of all the rows. What a pain. And I'm just kind of curious. We're dealing with the random number generator here in Python, but I'm curious if the average on each row is dramatically different than the average every 10 rows, is dramatically different than the average after all of the 100 rows. How random is random, in other words? Okay, so a couple of questions about that. Is this one loop? Is it one loop with control breaks? Is it nested loops, loops within loops? Is it sentinel? Is it counted? You know, that's what the point of this whole exercise is. I want you to start seeing problems and start thinking, wait, which pattern does this fit into? Do I have a sentinel? I don't see anything that says keep going until they enter quit, keep going until they enter 0. I don't think it's a sentinel, is it? I don't see any special values that are going to tell me when to stop. This is probably not a sentinel control loop. I've got counted, but anyway, we need to start thinking about that, rationalizing it and reasoning it out as we hit these problems. So I think it's one loop, but it's got control breaks every 10. Right? So we're going to go from 1 to 100, or from 0 to 99. We're going to have 100 rows. And then every 10 lines, we're going to stop. And we're going to collaborate and listen. No, that's a different thing. We're going to stop. We're going to do a control break logic. We're going to do some stuff. And then we're going to start over and do another block. Okay, so let's see how we do this. Okay, we want some pseudocode. How am I going to do this? So for each row from 1 to 100, inside there, I'm going to need to say for each column from 1 to 10, generate a random number, however we do that. And then what do we do with it? We got to add it to the end of a row string, right? We've done that before. I'll have to think about what all the components were to, I remember I have set row value to an empty string. So add that string to that random number to the end of a row value, okay? And then keep doing that. And then when I finish the 10 columns in a row, but I've exited the inner loop. So I want to print or actually I can't print because that's going to go to a new line. I need to add a colon to row value. And then I need to add the average of the row to row value. Everybody with me still?
Yes.
And if I do that 100 times, then I've generated every one of the rows that I need to generate. So I could stop there. I could go test it, make sure that that's working without the control break. Let's keep plowing forward. Here I have exited the outer loop. And so I'm going to print my total average, however I calculate that. I'm creating a lot of to-do items for myself, aren't I? This total average, how am I supposed to calculate that? Where did that come from? Okay. And then we said something about every 10 lines, I'm supposed to do something. Right? Do some kind of a control break every 10 lines. So that doesn't go inside here because this is the inner loop. This is doing each of the columns. Then, oops, then at the end of the columns, we're doing, I do my 10 random numbers, then I add a colon to the end of it, then I do the average at the end of the line. But then before I go to do the next row, I need to do something else here. So this is where I would do my control break logic. Is it the 10th row? If so, print a subtotal line, right? I don't know how I'm supposed to do that, but every 10 rows, I'm supposed to stop and print a subtotal line. And then keep going, do more rows. So if I was to stop there, I think that captures everything in the original problem, right? I've still got a bunch of missing pieces like this total average. I still haven't figured out how I'm going to calculate that. Total average is what, right? I have to figure out what that is. I haven't figured out how to say, is it the 10th row? I haven't figured out how to do my subtotal line. I'm supposed to somehow do the average of all of these, this block of 10. But I think I've captured what I have to do. I just haven't figured out exactly how I'm going to do that. Now, if you guys stopped here with your pseudocode and you turned it in like this, I would probably be inclined to give you full credit for the pseudocode part, because when we looked at the problem, we pulled everything that the problem says and figured out how to shoehorn it in there. It might not be in the right place. We might not have answered every question, but we captured it all. We moved it all from the problem into the pseudocode somewhere, somehow. That's good. That's what the pseudocode's for, is to get organized. So that would probably be sufficient. My point there is, you know, I've been trying to remind people, don't overthink the pseudocode. It doesn't have to be pages and pages long. It doesn't have to be super detailed to which variables you're using all the time. If you know them, if you're like, ooh, I've seen this pattern before, I need a variable like the row value thing. Hey, we just did that problem. So I knew I'm going to have to concatenate stuff to a string and then print it at the end of the loop. So I knew that. So I just captured it. Okay. What time are we getting to? Wow. Have we really been going that long? Okay. You remember that, I'm not going to finish this one then. That was the main point I wanted to show you. This is a really complicated problem. This is the pattern you would use for doing a control break problem. That's fine. I trust that if you went and beat your head against your desk for an hour or two, you would figure out how to do that, or maybe not, or maybe you'd have to come back and ask for questions and stuff. But I wanted to do the part where I captured all this stuff on a complicated problem into the pseudocode. Mission accomplished it. So before I run out of time, I'm going to stop there. And so there's this really fun one that I wanted to show you. So when I was learning how to program, I mean, I was probably this tall. Okay, maybe not that tall. But my first program was a TRS-80 Model 1 from Radio Shack. It had big, huge blocks on the screen for the pixels. It was very primitive. But being the nerd that I was, hey, I'm proud to say I was a nerd in school. What I would do is somebody would leave their computer unattended, and I could go up and I could type in about 6 lines of code, run it, and produce this on their screen. So they would come back and they're like, where the heck did that come from? Okay, just like a little party trick or something. Okay, so I just spent 10 minutes the other day and did that in Python with the turtle graphics thing, and thought I would just show that to you. As remember the slide earlier where we had the simple Lego model on the left, and we had the cool model on the right? I just kind of wanted to show you this running. Let me bring up Bonnie again. I can probably do this in Bonnie. Open. Okay, so here is the Python script that does this. And if you notice, it ain't that bad. I mean, if you forget the fact that I created a function up here, okay, ignore all that math stuff, okay? Got some initial housekeeping stuff. Okay, when I get down to here, you can understand what this is doing, I think. For degrees in range 0 to 180, right? So I'm going to do one arc of the sphere. Pen up, go to pen down. Okay, I'm just moving my starting pen. Then the inner loop for degrees the other way. Okay, so I'm going to sweep both directions, up to down, left to right. And inside here, here's the work that I do. From the starting point, go to the next point in the arc. All right. So if you forget all the math, all this is a counted loop inside a counted loop. Right? So if I run it, hopefully, if I don't have any bugs, zoop, 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 zoop. It's not too bad, is it? Yeah. And I mean, there's the code. Page 1, page 2. So if you pause the video and you type in those instructions, then run it, you can draw a sphere on the page, or even cooler stuff, you know? And all this is, it looks really, really cool, but all it is a counted loop inside a counted loop and a bunch of math. That's all. No, a little bit of trigonometry. Yeah, so this is the kind of stuff, that's what took me a long time when I was in high school to figure that out. Once I figured it out, it wasn't too bad. I'll even give you like, this is a good practical application here for you. So if you don't know what the math stuff does, I just created a, I created a spreadsheet. So I'm going to go from degrees 0 to 360. So I just typed in this column from 0 to 360, counting by tens. And I don't know what I'm doing, but I'm going to say in this column, tell me what the sign of that many degrees is. And I can see it goes from 0 up to 1, back to 0, down to -1, back to 0. So it's kind of sweeping around a circle. And then I just sat there and I thought about it. What would I have to do to calculate the X and the Y value where I want to start? And I just started playing with it. A lot of it was trial and error because I didn't understand the math at that point. Eventually I got it where, ooh, I actually like those numbers. So I moved that function over to my Python code and did my counted loops and looped over the degree values. Boom. I didn't do it right the first time. I had to trial and error with it, play with it a little. But eventually I got it working. Okay. So I wanted to show you this illustration because this is exactly how I solved that problem in high school. And I just said, show me the values. Let me see what the values would be if I looped over them, and I trial and error until I figured it out. Okay, and it turned into this. Okay, for degrees equals 0 to 180. For degrees equals 0 to 180. Draw. That's all it's doing. So have fun with it. You've got an assignment out there that's due in a couple of weeks after spring break, so I didn't want to pressure you and make you have to do a bunch of stuff. You know, it's the same assignment I gave you last week. Yeah. Sure. Oh, well, that's a good example. Good question. You don't have to have that to make it work. Well, what I wanted to see is if I run it on this computer, how long did it take to run? So it took me 6.29 seconds to draw. So that was just, you know, remember like the little dashes and the row headers and column headers? That was just extra window dressing that I added to it. So if you're doing this on an actual computer, an actual reasonably fast computer with a good graphics card, it might run real quick. Yeah.
With the time module, is there a way to just add as like 1 second to that so we can gaslight the user who thinks it's not running at the right time?
No, I mean, you can do set time on the computer. You can change the clock, but you know, you run into other stuff. And I set this to speed 0 to fast. Turtle Graphics, that library in Python, you can make it run slower so that you can actually watch the little shuttlecock move around the screen. That's kind of the idea of Turtle Graphics is you don't just draw the picture, you get to watch it draw the picture. So anyway, have fun with it. But I wanted to show you that just to hopefully spark your imagination that you can do some really cool stuff. Yeah. So in summary today, we did loops and loops and loops and loops and loops. Practical examples, how to flowchart them. Hopefully everybody will be able to do your flowcharts now. Yeah. So what do you got? Anything?
You said the final, that final project, is that going to be given by you or do you have to say something?
Final project. I haven't